Welcome back to Munro Live. So right now we are very deep into the teardown of our Kia EV9. All of the major systems and components have been removed, so they are individually being analyzed. And this gives us the opportunity to really look at some of these systems more in depth and trying to understand the reasoning, the technology, the manufacturing methods behind these components is something that's very, very important to me. As you see, the Cybertruck teardown is almost gone. There's really not much left of it. I don't know how many more videos we'll be able to get out of its systems, but look forward to any future videos if we're able to find anything. So let's go ahead and start a look at the EV9 doors. As we start to review the construction of this door, I'm going to remind you of some of the things from the Cybertruck door that we looked at recently. So this is a stamped steel door. Of course, not the stainless steel like the Cybertruck. Because of this being a more traditional stamped steel construction, all the way around the perimeter we have hemmed metal. So basically the outer skin and then the inner door structure are brought together, and the outer structure hems around to capture the inner structure. That was not possible in the Cybertruck because of that unique, thick stainless steel exterior. The material could not be stamped or machined in a way to give that 180-degree bend. So because of that, it had to be laser welded all the way around its perimeter. We don't have that here with this traditional stamped steel door. Now, this door being steel, this weighs roughly 20 kilograms. A door of roughly the same size in the Rivian R1T that we tore down is an aluminum door, and it's only 11 kilograms. So there's a lot of weight savings which benefit the battery. However, material costs are higher, and some of the manufacturing methods do cost a little bit more. So it's a decision that the automaker has to make. Are we going to go with traditional steel? Are we going to use aluminum? Now, one thing that I think is kind of funny, when I've worked with all of the individual components on the OEM level, lots of times they come to us and they say, we need weight savings, we need lighter weight. So we do everything that we can to make the door module lighter, the door lighter, the trim components lighter. And then when they put it all together in assembly and they close the door and they see the feel of closing that very, very light door, they end up putting a steel weight inside of the door to give that more of a clunk feel. Now, I think that's hilarious. I'm like, do you realize how much money you spent to save weight to then put in a block of steel to make the door heavier to give you a feel that you would want? If you would have allowed us to save the money and use a traditional steel door, it would give you the weight that you have, and you're not paying for all the excess assembly and manufacturing methods using aluminum. So it's kind of funny. It's like they almost don't think from the end to the beginning. They think of where they are, where they want to go, and they can't work backwards. Let's look at this beam. This structural member inside of the door is what we would call a crash beam or an anti-intrusion beam. This one is made of just a piece of tube steel. Very easy to manufacture. Basically, all I'm doing is cutting off the ends and welding it or adhering it in place. Now, you could use something like this, which is very, very low cost for manufacturing, but it might be higher weight. Or, of course, this is a Kia. Let's look at the Hyundai Ioniq door, which is basically within the same family. So here's the Hyundai Ioniq door. This is that anti-intrusion or crash beam. It is just a metal stamping. Now, this stamping, though could possibly be lower weight than the tube, that is much more expensive processing. It's more expensive to build that component to put it into the store than it is to just use a cut-off tube. So you have to look at what benefit am I getting as a manufacturer? Is that lower profile, or do I need the space within the door? All of these things you have to think about and really understand, where am I going to save money, or where am I going to design something that is the best for the vehicle? So the Kia EV9 has a door module that is very similar to what we saw on the Cybertruck. Now, there's a couple of unique things about this door module that I would like to make mention of. First, look at that, handles. They actually included handles into the injection molding. Makes it very, very easy for assembly. Just bring this part up and then pop it into place. That's nice. All right, But there's one weird thing. This is the front door. The front door has this nice door module. When we looked at the Cybertruck, there was a door module like this on both the front and the rear. Not on this one. Here's the rear door. It does not have that load-in module assembly. The guide and the mechanism for rolling up the window is bolted through the door here. So this is a blind install. I have to load in that component, bolt it in place. There's a motor at the bottom. So here's the question. Why didn't they use the same manufacturing method on the front door as they did on the rear door? This is something where, when I look at what we do here at Munro, I almost feel like we're automotive archaeologists. We look at the what. Okay, this is the what that has presented to us. We look at the how. We look at, all right, what evidence can I see that indicates the manufacturing methods that would have had to have been in place in order to create this what? And then, based off of experience of working with OEMs, working with suppliers, we try to anticipate a why. Why did it end up that way? The easiest why, that, again, this is speculation on my part, is because this door and the rear door structures were either developed by two different people or developed at two different times. So if I have the overall vehicle and I've designed something that's very, very efficient for a front door, and I carry this over across multiple vehicle platforms, that's nice. But now, if it's a unique vehicle like this, a 3-row vehicle, I have a rear door, which is only for that style of body. I might be kicking down the road a design that is much older just because I don't want to put in the money, I don't want to put in the resources to design something new for a low volume vehicle. And this may be, when it comes to Kia, a lower volume vehicle. So if this type of a structure is carried over on many vehicles that have a front door, the rear door of that size may not be updated as quickly. But in looking at this module, there's something else about this module that I would like to make mention that is an improvement off of the Tesla Cybertruck design. So let me get that Cybertruck module. So here's the Cybertruck door module as it would be presented to the vehicle. I would have to take this module and with the tracks for the window, feed them into the door, locate it in place, and then screw it off. So what do I have? I have these metal tracks with a cable system secured to the back of this plastic panel that is enabling my window to go up and down. All right, we need to think about first principles. And in doing that, we would want to say, do we have two different parts? Yes, these are completely independent, unique parts that are being brought together. Okay, do these parts move in relation to each other? No, these get screwed and fixed. There is no relative movement between the door module and this track. Okay, are they made of different materials? Yes, they are. This one is made out of either steel or aluminum. This one is made out of plastic. Do they need to be made out of different materials? Well, maybe not necessarily. If they don't move in relation to each other and they don't need to be made out of different materials, this should be one part for normal first principles. So let's look at the EV9 door module. So that metal rail that the window guide or attachment mechanism rides on is molded directly into the plastic panel. The only thing that we have added to it are the cables and the retainers themselves. That is a great cost save. It's a labor save. I'm not bolting on these extra materials. This is wonderful for this vehicle. Now, why couldn't Tesla do that? Well, I'm going to kind of give them an out, and let's go and take a quick look at the Cybertruck door. So here's the module located or installed to the Cybertruck door. We know that we have a pair of tracks that are inside of here that feed up into this metal panel. These caps actually cover off the windshield attachment. But look at how big of a section I have above the module. Because these tracks have to go up so high above the module before I reach the edge of the door, That is why they had to add on that extra extension. But I think that's an excuse. Now, here's why. If I'm a person designing the module, I'm going to say, well, this is the door that they gave us to work with. I have to work within that. However, that door is made by Tesla too. You're both Tesla. Why can't you work together to make something that's a little bit more efficient? Why couldn't this line have been up a little higher? This happens all the time within the bureaucracy within automotive companies. Everyone thinks that they have a set of requirements or guidelines that they have to work to, which may or may not actually be true. Now, they may have had a discussion and there may be a structural reason why they needed this much steel above. I, of course, don't know what that discussion is, but that is an opportunity that I would say in the future that they could look to integrate that module even better. I wanted to make mention of the glass and how the glass is held to the window module. Now, when we looked at the Cybertruck, I did a comparison to the F-150. Normally, if I have a full framed door, I do not need a very secure attachment of the glass because I am not trying to set an angle of the glass because it's riding inside of a track in the door. So on the F-150, there were just holes in the glass that snapped into attachment features that were on the door regular module. This does not have that. I have a threaded attachment on one side, but yet I just have like a gripper panel on the other. So let's look at that module. After I feed in the glass, here are my points that I attach to those points. One feature is going to go through the glass and is actually going to screw to its attachment. The other one sits inside of this groove and basically just gets clamped to the glass. That's a little bit more labor intensive and a little bit more expensive than the style that we saw in the F-150, which literally just had a plastic snap feature here and locked into place. Because this is a full frame door, I think that that is something that the EV9 might look at in the future. Now, I don't want to get too deeply into it. However, this is the door latch and handle mechanism. This appears to be somewhat extreme. All of the different functions and mechanical features within this handle would have to be analyzed, which we have not done yet. I just wanted to make mention of how extreme this mechanism really looks to be. Now, I need to make mention of a decorative feature that I personally do not like on cars, and that is the lower door cladding. You'll see the lower skin of the door. This is all A surface, and then it is stamped in to provide an attachment point for this decorative component. This could have been left all A surface, going down to the bottom hem of the door. They decided not to do that. They have to plug holes into this skin in order to attach this component. All right, because they plug holes, they're trying to seal, so they have either a foam rubber seal around all of those attachment points. We have high gloss upper, mold and color matte lower, and then a painted decorative insert. In order to do all of this, this is many pieces in this assembly. Some components are being welded together, some components are being snapped together. There are screws that are holding in this inner filler panel. This is a very expensive decorative component that, in all honesty, just becomes a piece of junk if it's hit on the freeway that flies out into the middle of the road that you cannot really repair as easily as I could repair the steel. All of these parts would just have to be thrown away and replaced. I mean, you see how damaged this gets just kicking around here in our shop. I personally don't like these features. They're very big, they're bulky, they're expensive for what they're trying to do. So in the past, I have talked about the manufacturing methods for the doors and some interior trim. And I've given the criticism, basically I called them Taco Bell interiors. They all have the same ingredients. They just mix them up in a different way to pretend that it's something new. Thermoform or vac form skin to give you that nice soft touch, some sort of an insert, an actual sewn wrapped component being attached to it, injection molded plastic on the lower, fairly standard. But let's look at the back. When I look at the back, I'm trying to see all of the layers. I'm trying to see what is actually happening. I see a mixture of screws. I see some weld points. So this is being screwed together and it's being welded. Okay. But I'm looking at the screws. I'm thinking, wait, this is the same part. I have a screw here. I have a weld here. I have a screw here. Why would I both weld and screw the exact same part? Well, basically, I think that they're using fewer screws to provide the initial attachment, taking this as a sub-assembly, putting it into a fixture. Then the fixture has the weld horns that come down and weld all of these positions. Okay, that is an option. Installing all of these screws and installing them all in the right place is a little labor intensive. Let's look at the Tesla Model Y. So here's the Tesla Model Y door. Notice something. There are no screws. Everything is being welded together. So all of these parts are loaded into a fixture loose and then being welded in either one or two steps. Sometimes the layering requires it to be 2 steps. But from everything that I see here, it looks like it's being done at once. This is efficient, however, it requires more thought in your fixturing and in your capital equipment. This allows for that pre-assembly, which is holding things together, but then goes into that welding fixture, which may not be built up as much, may not hold the parts properly, which is why you're relying on the screws to initially attach. Now, I know it's very hard to see on this part. The features that I want to talk about now are very, very small. But you'll notice this. This is the vinyl. It's a foam-backed vinyl. That is what's being applied to this upper. All right, that is a thermoform, vac form, IMG, however you want to call it. The skin is heated up and then it is sucked and pressed to the panel. See these little tiny holes? Those are to allow air or gas to escape between that skin and the panel. So if I show you the front of this door with this trim piece removed, this is the A-surface skin. Now you'll see how tight this is being pressed down into this cavity. There is a grain or a texture on the part that the customer is going to interface to. There's no grain or texture on this material when it's raw. So the tool that is heating this up, forming and adhering it to the panel is also providing all of this texture. That pink look that you see to the back of the foam is a primer. That enables them to put adhesive only on the plastic substrate. They don't have to put any adhesive onto the foam itself. The primer grabs right to that plastic. Now you'll see this raw cut edge around all the hidden area, but we have some parts that are not hidden. Look at this corner. There is a tool that has fingers that press in and press down and heat up to try and lock that corner in place. But you'll see how the material ripped and stretched. The material is basically being melted in place to that plastic substrate along those edges, and it's stretching and tearing. You have to just watch that type of a feature and watch those fingers so that you don't end up damaging anything that's going to be exposed or visible to the customer. So whenever I or we tear apart a vehicle and look at these components, we're trying to understand what did they make, how did they make it, because I want to understand the capital equipment. How many stations were required that this had to go through in order to screw the components together, in order to thermoform, in order to set and lock, in order to weld. That all builds up into cost. It all builds up into process. I still give the explanation of a screw, a simple 3-cent screw. It's easy to miss, easy to ignore. However, the cost is not in the screw itself. The cost is in using the screw. having a box of screws delivered to your loading dock, moving those out to the assembly line, having a storage area, feeding someone at the assembly line, having a screw gun on the line that is now grabbing that gun, grabbing that screw, putting it into place. Having to move with that screw gun from this spot to this spot to this spot to this spot. All of that is time on the assembly line. All of these welds can happen in one shot, in one fixture. By me trying to calculate all of those decisions, I can understand what the costs are of this vehicle, of this component. I can then propose to the client, if you did it this way, you might have an improvement. However, maybe they did not want to spend the money on a fixture like Tesla may have. So for them, the screws are a cost savings. There is no one right answer. There is no one right way of doing things. And it becomes difficult if you're praising an automotive company because you appraise them for something being great today. They change it up completely for their next model year and you realize, oh, there was still more there. There was something that could be improved upon. So I don't want to talk about all of this stuff as if I'm being very, very critical of any one person. I want to show the decisions that they've made, how those decisions have an effect, and I want to see how they improve over time. I want to help them to improve over time. Again, if you look at design and it is complex, complex is not impressive. Complex normally means wasted effort, wasted material. If you look at something that is very, very simple, you normally will never get praise for something that is simple. But it is often harder to design a system that looks simple than it is to design a system that looks complex. So, thank you very much for watching. I hope you enjoyed this little review. There are still more components within the EV9 that we are going to be tearing down and looking at more in depth. Please stick around and see us in future videos. Have a good day.